Just wanted to welcome everybody to this webinar and appreciate everybody taking time out during their lunch, I guess, to talk about unmanned aircraft systems and aerial mapping and aerial inspections. My name is Matt Roberts. I work with DLZ, started in 2006 and been in consulting for a little over 20 years now. Been involved with the aerial mapping and drone technologies since 2016, and really excited to talk about this topic. It's become a forefront for another tool, I guess, for us in the surveying and mapping world. So let's go ahead and get started. Before we dive right into aerial mapping, DLZ's first autonomous craft actually was a boat. We still own and operate this particular boat. It's called the Z boat. We have a second autonomous boat now that we use to do hydrographic mapping of underwater surface modeling. And it pretty much works the same as our aircraft, where the autonomous features are all being controlled by satellites. So DLZ, when we first started looking in 2015 at this technology, we started looking at the capabilities, the intended use of what we would use unmanned aircraft for, the environment we would be using them, the cost, and the maintenance of the aircraft, either firmware updates or motors, batteries, this kind of thing that to keep us operating drones safely. The four aircraft that you're looking at are pretty much the four dominant aircraft that DLZ owns and operates. The two fixed-wing drones are going to be our mapping drones. They're the more accurate drones. The top left would be the EBX, which was our first fixed-wing drone, and the EB Plus, and the EBX, which is the one with the yellow background, is our most current fixed-wing drone. It has the capability of swapping out different payloads, different sensors, that allows us to do aerial mapping, orthomosaics, thermal mapping, that kind of high-end detail and very accurate mapping, where the other two are quadcopters, also capable of doing 3D mapping. The difference being that the quadcopters their battery life is not as long because they're working harder. The rule of thumb has been, with no headwinds, the fixed wing aircraft can get you up to 900 acres in 90 minutes on one battery, where the quadcopters are about 20 to 25 minutes to get you about 30 acres, about 400 feet above the ground. So again, no winds in that scenario. So the quadcopters are mainly used for doing video flyovers, and where we're recording, say, going down a corridor or a site and sharing in 4K formats, up to 4K formats. Most times 1080p is okay. The inspection multi-rotor that you see in the bottom right has the capability of zooming in. So if you have a very still day, with this particular platform has a good gimbal, you're able to zoom into certain features from a far distance. So that one does have that advantage. So DLZ has a total of 9 remote pilots that are certified by the FAA. We have 11 different drones that we're currently operating in 6 locations, and that gives us the capability to operate and cover just about all of DLZ's 27 locations and operating territories. And if for some reason we're not able to get there immediately, we do have the capability of throwing the small plane into the big plane and giving us an even more increased service territory. This also, if you see in this photo here, we have a survey crew chief with us. Our more experienced pilot, who's commercially rated, CFI, and then the other person being me, the drone operator, all three of us are able to fly to a site and literally get the mapping done and in the can and fly back home in the same day, which cuts down on cost. We don't have the travel costs, hotel stays, that kind of a thing. So we found that to be a benefit on some projects. Land surveying and mapping department here at DLZ is no stranger, just like most consulting firms, to the asset life cycle that you see here. Surveying and mapping folks get to touch just about every feature on this life cycle, from maintenance, planning, design to construction. The key takeaway here on this slide, besides the subsets, is the geographic information must be maintained throughout the entire process. In other words, the coordinate system that you select at the beginning of the project needs to be maintained throughout this entire asset lifecycle. That's imperative. Otherwise, the sharing of detailed information doesn't stack well. It doesn't relate to each other, and unfortunately, the history and of the data could be lost. So this is a really good slide that I like to share with folks to try to put in perspective from land surveying and mapping. And drones is just another tool that gets to touch this asset lifecycle. What you're seeing here on the left is basically one of our drones in the field. This particular drone is being set up and ran by a laptop. And before we go on site, we have everything preloaded as far as the maps, as far as the flight planning. Each one of these green dots that you see on the right is an actual photo that's taken or a waypoint. It's understood how far it is above the ground, and each one of those photos is geospatially tagged. And that would translates and imports into our photogrammetry software. Looks like this. So those green dots are now blue and green dots, representing good photos that have been geospatially tagged and build what you're seeing below the photos as the surface model. So each one of those pixels from the actual photo is then translated and resectioned down to create a point cloud or a physical point. The red ones that you see in this are actually points that where there's bad data. Probably the drone was blown off course. So the software is sophisticated enough to understand that those particular points from those two images are not good enough for building the solution to our surface model. So when we talk about mapping using drones, it's essentially no different than conventional aerial mapping. Folks that have used conventional aerial mapping over the years, we're basically doing the same thing with drones. The big difference is we have to fly 400 feet or less. So that means that the level of detail that we're getting is actually better in some cases compared to digital photogrammetry that you get from a helicopter or airplane conventionally. So one of the big questions for both conventional aerial mapping and drone aerial mapping or unmanned aerial mapping is the quality and the quality controls that we have in place. So what we do at DLZ, and it's always preferred that we have ground targets set and located prior to doing a flight. On the left-hand side, what you're seeing here are chevrons, and the tip of those chevrons are basically located survey grade, where those points horizontally and vertically are brought into our photogrammetry software, and that becomes part of the solution. So all those point clouds are moved and translated, rotated by the software using these aerial targets. And the software also generates a 10-page quality report showing the action average of each one of the aerial targets and how we how we hit them. Basically, it's comes down with an average. So you have 20 points or 20 aerial targets set on a site, and it'll give you an average, or you can drill down and see what each one of those aerial targets transposed and what the software thought it should be versus what it came out to be. So we know that the mapping or the quality of our mapping is accurate. Something that conventional aerial mapping firms have always done and we're now doing is removing unwanted surface data during the aerial mapping process. This particular example is of a landfill where we have an active landfill, and it's very unsafe condition to conventionally survey, put folks out there walking around this. So using a drone was real big advantage. And the cost to do conventional aerial mapping for this smaller site just didn't make sense. So this is one of our first projects, and it's a good example of what we need to do to clean up surface data, or the end product being contours on this project. So what you see in the top left and bottom left images are vibratory sheep's foot roller, and you need to overlay both the orthomosaic and the contours to be able to know that that's a feature that we don't want to be part of the surface, and ultimately gets clipped out and removed, so we get good volumetric quantities, or the earthwork quantities are not going to have that sheep's foot roller in it. Flood mapping, very popular, becoming a very popular use for drones. We get a lot of floods sometimes of the year in different parts of the country, 100-year up to 200-year flood frequencies. We could be called and dispatched out directly after a large flood and have been asked to do so. This particular example is out in Indiana, where we had a flood, and our folks were called out to immediately get good existing conditions, both doing video, still imagery, and then data in the can to then build 3D models. And this is a major benefit when we start looking at what does this mean in the future. Should we get a 500-year rate frequency or something really large or some sort of dam failure? We can then take that surface model data and raise the elevation of those potential floodwaters to see how they interact with structures and roadways. Reality modeling using this technology inside of our photogrammetry software, we're able to basically take the orthomosaic and drape it on top of the point cloud to build what's called a reality model, which allows end users to flip around in 3D space and be able to actually see and I guess interact with the data that we captured that day during the flight. And this particular example has been greatly enhanced, but again, it's an orthomosaic draped on top of a point cloud. So at any time we can stop this model, take measurements out of it, get elevations, and extract data, and even be asked to create a survey grade base map, which is what we did for this project, being a hospital out in Indiana. So what you see on the left is the actual aerial mosaic, and on the right, obviously, is a CAD file of the existing conditions that have been built off of both conventional survey data and aerial mapping data. So another example of reality modeling in a visualization world, 3D world, we're able to take existing conditions from one of our flights and then add in this case, a proposed bridge. So other end users, residents of this community can see what that bridge is going to look like before it even gets into the design stages, which is a great benefit for folks that maybe don't understand the way things get built when you're looking at 2D plans. Having this 3D model is a great benefit to explain a project and to get private ownership buy-ins also. So great tool. And this is just another visualization of it. This will actually play, but it'll slow it down. So I'm not going to play this one this time, but the next one I will. So moving away from mapping and modeling, the inspection and visual documentation using drones is also another major benefit. When we're talking about asset infrastructure assessments, environmental monitoring, pipe and aerial inspection surveys, and tanks, bridges, towers. And the two big bullet points here that I'd like to point out is saving downtime and reducing occupational risk. In the case of towers or bridges, you're still going to need to do those visual inspections. You're still structural engineers are still going to need to go out, do some soundings, but maybe before we actually go out and do the inspection, we get some good visual documentation of these assets and infrastructure. So this is an example of one of our drones doing a bridge inspection. This particular bridge out in Indiana, we had a farmer accidentally hit some of the structural members of the bridge, and it was an unsafe bridge for any vehicle to get out on there, and we needed to get some up close shots of the connections where the damage was done before we sent anybody out to actually do the inspection to get a really good assessment. So just an example of what it looks like in the field. Another bridge example I wanted to present on is the I-490 bridge in Cleveland. This particular bridge is a really good example of using multiple technologies, not just aerial mapping, but also 3D scanning below the bridge. The challenge of this bridge, before we even started, was it was in a controlled airspace, Burt Lakefront Airport, and we had to get a permit from the FAA to fly in this airspace. And it's a particularly busy airspace from the standpoint of having Burt Lakefront Airport and 5 different heliports in the area, hospitals and the like. And also we had Cessna aircraft doing flyovers on gas transmission lines. So we had to have 2 FAA aviation radios. We had tower on speed dial, and we had multiple visual observers, VOs. So this cut down the risk and kept us flying safely. There was one circumstance where we had to bring the aircraft down lower because of the Cessna that was doing some inspection work. But for the most case, as long as we were flying at that 400 feet or less, we're really not in any risk in this particular location. So getting that permit from the FAA really was not a problem for this particular project. So I guess I should back up one here. So what you're seeing here is the orthomosaic DSM, or digital surface model, and the thermal radiometric. All 3 were taken in 2 flights, and 1 sensor, and we finished this particular flight within about 2 hours. And like I said, we were also asked to get good existing conditions below the bridge. So DLZ has in our arsenal 3D scanner that you're seeing in this image here, and we were able to extract more points from the point cloud from the 3D scan, and both thermal and points from the aerial. So we have a top-down approach point cloud, and we have a point cloud below the bridge. that allows us to get really good existing conditions, map them, extract out figures of what you're seeing here, sprawls, bridge sprawls underneath the deck. And also here in this example, you can see highlighted in blue off to the right image of a figure that we extracted from the point cloud. And then during the inspection, physically stake on the top side of the bridge. So as we're doing our bridge inspection, dragging the chains, taking asphalt cores, our survey crew chief is locating those assets and then also staking out the below the structure items at the same time during the inspection. We're finding this to be of great value, and I think it has it's going to have our place in bridge inspections in the future for sure. The thermal is also kind of a case study where the idea is we're able to detect, we think we're able to detect bridge delamination because of the temperature difference of a void in the pavement versus no void. So again, another top-down approach. When we're assessing bridges, we're starting to look at thermal as being another tool for helping us support decisions being made by our bridge department. Progress tracking, construction sites. So we have a raw land situation where we have a hospital being built in Indiana, and we wanted to get some aerial of the progress of this construction site and how this hospital is being built. Great tool for just that by itself, just looking visually at how this project evolves. But besides just getting the regular imagery, we're also taking the time to fly it autonomously and get good 3D data. So what you're seeing here is just a zoom in of a stockpile. And that stockpile, should we be asked, well, after the project is built, we can provide a volumetric of that quantity from that day. So having just that data in the can can be a benefit should certain quantities or volumes need to come into question. This is just another example of a client, one of our industrial clients at a steel mill, where we're asked to get multiple volumetrics on multiple stockpiles, different quantities, different material types. Great tool for that. And it allows us to get away from the conventional aerial mapping approach, use drones, and we were able to reduce costs. And this allows some of our clients to maybe, instead of just annually, semi-annually or quarterly, fly these sites to get more accurate quantities. As built documentation, this particular example, our transportation department designed this roundabout. We were asked to go out and get imagery of the project after it was built. And this particular example, again, besides just getting good imagery for a show, we also flew it to get good 3D data. No one to this day has asked us for any of 3D data to be extracted, but should it come up, future generations, it now exists somewhere in cyberspace or on our servers rather, and we're able to extract and build good models off this, good as-built models at that. This one I'm going to just quickly get out so I can play for you. This is an example kind of sped up in Indiana of traffic analysis. Our traffic folks still go through their due diligence using the DOT process of doing traffic counts, traffic monitoring. This again is just another tool to help with our decision making of this intersection. The drone was able to hover for approximately 25-30 minutes and collect during peak rush hour all these automobiles, and if there's any question of the traffic count data, we're able to go back to the drone imagery now and isolate a key time when the traffic volume was at its highest or is in question based on our other data. Inspection of hard to reach places. This particular example is of a shaft site in Columbus. This shaft leads down to a tunnel, and we're able to fly our drone off GPS, no longer having the telemetry software driving. This is a manual control kind of setup. Again, I'm going to get out just so I can share this. And we're able to take a video of this shaft and record its conditions. And while we're recording this video, we're also able to build a surface model from it. So still imagery definitely is the more precise way of building 3D models from drone data. But this particular case, we wanted to get in and out as quick as we could. So we took the video data, or the pixels from the video, and still able to create this 3D model. Not as good as building a model from still imagery, but you're still able to get some good volumetric quantities, some good dimensioning, and isolate some elevations should that be of interest. Structural inspection goes without saying, just like bridges. We have the advantage of sending drones up now to look at connections, to look down chimneys, to look at the top of towers. The asset management, environmental monitoring. Again, we're saving downtime and reducing occupational risk. Before we put a guy on a boom truck or a man lift, maybe we should get some drone imagery first, so we know exactly where to put that boom truck, or where to put that man lift. Certain areas we might be able to ignore, and the areas we want to focus in on, again, saving time and money. Historic preservation. This particular example, DLZ was asked to get good modeling and visualization of a monument that had to be relocated. And prior to the monument being taken down, we wanted to get a really good existing conditions model of it. So when it got erected to its new home site, we're able to make sure and verify that it was being erected back to its original state. So another great tool using either 3D scanning or aerial mapping. Thermal imaging becoming popular. Obviously there's handheld FLIR cameras. A lot of folks use those, and you can easily point to handheld FLIR camera at this particular example at Mishawaka High School, getting heat loss and determining where the heat losses are, detect the worst case scenarios of the building. The big difference, obviously, getting thermal mounted onto a drone, you're able to get the top-down approach and see the roof and the other higher end areas that you would not be able to get with a handheld. Another becoming popular is when we talk about mapping in thermal, the technical name is thermal radiometric mapping. And just like building our photogrammetry maps, the thermal is built the same way, where we're taking a bunch of thermal images and geospatially stitching them together. So good examples of using thermal mapping for tracking plumes, say in a situation where you have a river and there's some sort of discharge at a different temperature going into a river and going downstream, and we want to know how far and how long it takes to get into the river system. We're able to map that particular temperature difference now. Or we have maybe at a lake, we have some sort of environmental contamination going on. You would expect that temperature to be different going into the waterway. So time and place is obviously a factor of getting this data, but it's now another tool, and again, helping us build good decisions on these particular situations. Here's another example of a tunnel. This is actually a 27-foot diameter tunnel that DLZ designed. And this is the portal structure where the tunnel starts and goes horizontally into 6,000 feet of earth. And we were asked several times to go out and get good existing conditions of this site. So we now have a history of flying it 4 different times from start to near finish. And this is a great example of what it looked like during construction. In this particular image, we're seeing large number 11 rebar before they were permanently entombed in a large concrete mat. So now future generations not only have the imagery, but we're also able to build a model and get you a good location, elevation of these rebar and how they looked before concrete was poured. Yeah, I'm starting to get some questions. I will get into the questions here at the end. I promise. I have at least 10, 15 minutes, and I'll do my best to answer questions. So hang in there. We're getting close. This again is you're seeing the crib wall and the portal structure flipped up in a space that we're able to create a video and share with other end users, again, so people can see how much we captured, the limits of what we captured, so we can better share what kind of models or 2D plans we can build from this information. Another very valuable tool is live streaming. So we're able to capture with our quadcopters 4K footage and share it back through platforms like YouTube at a 1080p rate. So if we have folks in other offices, other design teams in other states that need to see what a site looks like, we can send a drone operator out on site, and certain people can ask the drone operator to move left, move right, pan left, pan right. And this is becoming a great tool for folks that are just starting to want to understand the conceptual plan for a project and get a good idea of the existing conditions well before any surveying or design gets started. So we should talk about limitations. We're never going to get rid of boots on the ground. I want to stress that field surveying is still always going to be a big part of what we do. We're always going to have brush lines, tree covers that are going to get in the way of getting good aerial mapping data. It's always been a problem with conventional aerial mapping, and it's still going to be a problem with using drones. So we still have to send our field folks out to get these areas. Ditches, if they're not mowed or very deep, you're not going to get good surface data in those situations. Obviously, weather is a big one, and knowing your protected airspace, which I'm going to get into on the next slide. Sites that are flat and have little relief, we found the technology to be limited. We kind of are in the, you have to make that decision. If it's so flat, are you going to get good 3D modeling from it? Still good for 2D planimetrics, but may not be good enough for your contours. So depending on the nature of your design, if the project's too flat, you might want to consider conventional aerial mapping. Privacy is a big one. So sharing aerial imagery of private property, or more importantly, publishing aerial mapping of private property, is not something we do here at DLZ. We will suggest that aerial mapping is used only for design or planning purposes, and it's our understanding that it will not be put on public display. So that's basically how we feel about privacy. And I think most people who are using this technology are pretty much tucking under that same idea. We're not allowed to fly at night currently, but you can get a certificate of authorization from the FAA to do so. So must maintain line of sight and be 2 nautical miles from the operator. So this means that if you have to maintain line of sight, you might have to get more than one visual observer, especially if you're flying large corridors and your operator's in the middle of 2 nautical miles and 2 nautical miles. You're likely going to need more visual observers along that corridor. So controlled airspace, I'll go over it real briefly. This this particular example is in Northeast Ohio and also a little bit of Pittsburgh. This particular area has all the just about all the airspace. I think every airspace exists in this particular area. It's a busy airspace. Class B Bravo airspace is going to be your larger international airports such as Pittsburgh and Cleveland. And what you're seeing in this profile view in Class B is what most pilots refer to as an upside down wedding cake. So drone pilots are allowed to fly 400 feet above the ground and underneath these shelves of the protected airspace. So these concentric circles that you're seeing here relate to basically how you see it over here. Class C airspace would be an example of Akron-Canton Airport. And then Class E airspace, Akron-Fulton, which is a little bit of different airport. Just a good example, most Class E airspace is 700 feet above the ground. But in the case of Akron-Fulton, it is actually goes all the way to the ground. So it's more like a Class D where you see it's a straight cylinder, which would be very similar to Burke Lakefront Airport, which is Class D. So knowing all these airspaces, where you're flying, as you get close to them, very important. Some cases, if you're far enough away from these airports, you can get what's called an instant COA or instant permit from the FAA via an app to fly that day. The closer you get to the airport, you will not get that instant COA. You will have to get a permit from the FAA, which could take 60 to 90 days. So that can play into the schedule, obviously. And there's some circumstances where you're just not going to get a permit. So solution to some of these limitations, knowing when conventional surveying data is needed well before you provide a scope to fly, having contingency plans, filing your Part 107 waivers, which is the permit I just spoke of. If publishing data, then getting property owner authorization and talking to legal folks about that. And keep your schedule open, allowing for the best weather windows. We typically like to pick 1 week and pick the day within that week that makes the most sense. So moving forward, the future of drones, we're seeing and tracking different payloads that are now starting to be added to drones. This particular video that you see on the left is of a drone that's going to drop a sonar and do hydrographic modeling and fly over a lake to get contours below the surface, kind of like what we do for with our Z boat and conventional hydrographic boats here at DLZ. Just the level of accuracy isn't there yet. So our preferred method is still going to be the Z boat or a conventional boat. But it's a good technology that we're tracking, and we can't wait for it to be more accurate. The video on the right is magnetometers, ground penetrating radars, and also they have different antennas for detecting gas leaks. So Again, the payloads have to be light enough for our drones, which kind of limits the level of accuracy that you can get. But you can see where we're going with this future, and really excited to see drones being used with these kind of techniques. So that brings us to the end. So let's see, we've got approximately 15 minutes. I'll start answering questions here via, if you just text in. Let's see, the first question we have, why would you want to fly at night? Good question. So one of the things that we were required by the FAA is to not fly over the general public. When we're doing our flight modeling or flight planning, we have our flight lines, autonomous flight lines and waypoints off to the side of traffic, off to the side of pedestrian sidewalks, and we're flying just off to the sides. Should there be a failure, we're out of harm's way. Now, if we're flying at night when the traffic is low or there's no pedestrians, we have the advantage of flying in these areas much safer. How can we get into the class for certification? So there are, I would suggest going to the FAA's website. It's FAA UAS, and taking a look at their guidelines and what's involved for taking the test. The first test that you have to take is a 60-question test, and then you have to renew every 2 years with a 40-question test. And on the FAA's website, they have different resources for studying for that test. There's also some great apps out there that can help you study for the test to get certified. So it's all through the FAA, and I would recommend checking out their website. What are we using for photogrammetry software? We're currently using Pix4D Mapper, which just about all the mapping digital photogrammetry softwares these days are kind of built off the same algorithm. The gentleman that created the algorithm, I believe, was from Germany, and he didn't get it patented, so a lot of these software companies were able to capitalize on that and build just about a very similar approach to building digital photogrammetry. So should an inspection result in violation and the violation case go into court action, is it legal to use the drone to obtain this information? If so, how would that be different than using aerial photos? That's a good question. I'm not totally sure. I mean, if the inspection result is, if you know there's a known violation, I'm sure there's still the same conventional ways of documenting with our on-site inspectors. If you find yourself, you're in that situation and you feel like you need additional documentation using drones, then I would recommend getting someone out there to further document, to further validate your inspection notes. So I hope that answered that question. Otherwise, feel free to reach out to me or anybody in our survey departments across DLZ. They'll get you in touch with the right person should you guys need some aerial mapping. So let's see. I think that's it. If nobody has any further questions, we'll let this adjourn. Again, my name is Matt Roberts. I work in DLZ Akron office, and if you guys would like to see more about this technology or learn more, just reach out to anybody in our survey department across DLZ. So I appreciate your time.